Thank you for joining us today. We are so pleased to be here, and welcome to the Tech and Space Leader Show, where we learn lessons from leaders of the next frontier. I am your host, Lisa Dreher, and I'm really excited to introduce our guest for today, Andrew Parlock. He is the founder and CEO of Space Phoenix. Welcome to the show.
Thank you so much.
It's so great to have you here. Maybe, Andrew, we could start by having you give us a little bit of background on yourself and Space Phoenix.
Yeah, did a lot of work in national security and national security space for some of the big primes, and made a decision that I wanted to go off on my own. There's just such a great place to be. You said it yourself, the next frontier. Um, so I knew I wanted to go off and do my own, but I needed some experience. So I left and went to a space startup doing Earth observation, did business development for them, kind of led North American business development for them. And they were what you called new space. But it seemed like a lot of the Earth observation stuff was just kind of old space wrapped up in a smaller, maybe less efficient or more efficient package, but just it seemed a lot like what I had been doing. So I went off to and really leaned in space manufacturing, which is really where I see a lot of the market going. This round trip, going from Earth into space to create something and then bringing that back for the benefit of humanity. But there's a big gap there. There's a big gap. There's not a lot of infrastructure. Um, and it's causing a massive problem. There's constraints on the market that shouldn't be there. So hence the idea of Space Phoenix and the whole premise of Space Phoenix. We don't do the rockets. That the launchers are being managed. We don't do the payloads. I joke all the time. We're as unsexy as space gets. We are the FedEx box van of space. We will get you to space and get you back so that you don't have to worry about the launch, the non-reoccurring engineering expense of a satellite, the operations. We will get your payload to space, help you complete your mission, return your product or whatever it is you're developing, your microgravity research or your small payload, bring that back for use here on Earth. So that's the whole premise of Space Phoenix, developing a fleet of round trip transportation infrastructure to space and back.
That's great. Okay, so I've seen a quote from you saying that you're basically third-party logistics for space,
Yeah.
and I really like that, and I like your idea of the whole FedEx thing. You're FedEx for space. So, can you talk a little bit more about how this differs from a traditional approach to launch and recovery of payloads?
Yeah, well, quite frankly, there is no traditional approach right now, right?
Well,
Yeah, right. We've done, I mean, going all the way back to Mercury, Gemini, the Apollo, we've done, delivery to space and return of humans. Everything's been focused on humans. But now as we move into this new space economy, and I mean truly new space economy, biotech being developed in space, space agriculture, next generation of semiconductor materials being developed in space. We need to develop these low cost, high cadence vehicles that will get we don't do humans, right? That's the expensive part of this all. Dragon does great. I mean, SpaceX. How can you say anything other than incredible things about their technology and what Dragon's doing? But that's human-rated spaceflight. Sierra Space coming on board with the Dream Chaser, very expensive, low cadence. A few other folks, expensive, low cadence. What's missing from the market right now is high cadence, cargo focused, ergo low cost delivery to and delivery from space. So I would take third-party logistics and go one step further. I would say we're kind of white glove third-party logistics. We'll take your
ah,
payload, right? We'll take your
uh-huh.
payload. We'll get you integrated into a satellite. We'll manage. We don't do the launch, but we'll manage finding the launch and developing those relationships so that your company can focus on what your company does. Biotech or advanced materials or next generation semiconductors, whatever they do, focus on that. we'll take care of all the rest, get you to space, manage your operations, return you safely, and deliver your product back. So it really allows these companies, these in-space manufacturers, these microgravity researchers that are already at the bleeding edge of technology to focus on that core technology. And I don't want to call space boring, but leave the boring middle part, getting you to space and back, leave that to someone else. It's how we run business today terrestrially, right?
Yeah.
Companies don't own their own fleets of trucks unless they're a logistics provider, right?
Yeah.
We're Baltimore based, so everything's Under Armour. Under Armour doesn't own its own trucks and hire its own drivers. They farm that stuff out. We
Yeah.
want to develop that type of efficiency in the space industry. So we want people to come to us to get their product through space and back.
Yeah. Okay. So you talk about returnable payload on demand.
Hmm.
Why is now the right time for this type of approach?
Yeah, so returnable payload on demand is just what it says, right? You've got a payload, we're going to get you up and we're going to get you back. And we want to do that on demand, right? Yeah, today it takes 18, 24, maybe even more months to get your product to space and back. We want to lower that down to under 100 days and eventually, we envision a world where you do that in under 30 days. We'll see if we get there.
Wow.
That's future. That's future. You know, there's an amazing amount of constrained capacity out there. There's a lot of people trying to get to space and back. I'll keep the numbers quite large, but there's a large number, hundreds of payloads that are backlogged on the ISS, right? So microgravity and in-space manufacturing research that needs
Mhm.
to get done if we're going to really develop this new space economy. So I think now's the time, quite frankly, for Space Phoenix's model. Space Phoenix starts with a small spacecraft. Actually, it's an image of it in the background. Hermes, less than 200 kilo spacecraft, getting 60 kilos up and back. So small. We move on to the Athena class spacecraft, larger, 250 kilos and larger. And then finally, as you can keep going down the Greek mythology, Zeus, 1,000 kilo spacecraft up and back. And I think we'll grow with the market. Right now, the market's trying to figure it out, right? We say in-space manufacturing, but the vast majority of what's happening in in-space manufacturing is in-space manufacturing research and development. We're past fundamental research. We know the next generation of semiconductors can be produced, or materials can be produced in space effectively. We know the next biotech can be produced effectively, but now we have to do the research and development of that. So I think right now, Space Phoenix's small, medium, large, or crawl, walk, run, or whatever euphemism you want to use, I think we're meeting the needs of the market. As the market's growing, we're going to grow with the market. Um, Commercial LEO destinations coming online, they're going to need as much logistics up and back as they can get. Rogue Space, a great partner of ours, and others like it, are developing unmanned platforms that are going to need as much logistical um, uh, capability as possible. And not everybody can be everything to everybody. So you're going to need the logistics providers. You're going to need the CLD, the unmanned platforms. You're going to need all that. And you're going to need all the in-space manufacturers staying focused on what they do best.
Sure, sure, sure. So where are you in the development process? Do you have a scheduled first flight, or where are you at?
Yeah, so our scheduled first flight, depending, a lot of things, a lot of if-thens. Our scheduled first flight will be end of 2026, December 2026. We start bending metal on our first spacecraft up at the University of New Hampshire's John Olson Center. I want to give shout out to all our great partners, but University of New Hampshire, John Olson Center, we start bending metal on the first spacecraft end of July. Um, Another interesting thing that Space Phoenix has done, and everyone says, "Oh my gosh, you're moving so fast. How are you going to develop a spacecraft that fast?" Well, first off, fundamental to our core business, we don't do payloads, right? The payload's the really complex part. We're going to take other people's payloads up. We're not doing launch. We're letting other people manage launch. So we're developing a cargo agnostic spacecraft, a payloadless spacecraft that will enable people to get to space and get back. And we're using, especially with Hermes, our first spacecraft, our first class of spacecraft, proven off-the-shelf technology wrapped in a really novel business plan. I say this a lot, and people, a lot of our investors ask this question. What's your core technology? What's the IP? What's the patent for Hermes? And I say, right now the industry is not technologically constrained. The industry is capacity constrained. So
Mhm.
we're trying to develop as much capacity as possible. There's going to be time for patents. There's going to be time for pressing the pedal on innovation and new technology and novel technology. But right now, we need novel business plans that use existing technology to solve this capacity issue.
Right, right, right. So it kind of seems like vertical integration has kind of dominated the space industry, I guess historically.
hmm
How do you see Space Phoenix kind of enabling more flexibility and scalability of that whole ecosystem?
Yeah, SpaceX came on the market, and they were vertically integrated on purpose and by need, right? Man, there wasn't the market for a lot of the commercial technology, so they did it themselves, and then that became the way everyone did business. Everyone just developed everything themselves, but it's not that way today. We've actually developed a concept, we call it rapid tactical system integration. It's a really fancy way of saying if we're going to move quickly, we've got to use proven technology. There's folks out there doing things as good, if not better, than we could do them. We're going to bring that technology together in a novel platform with a really great business model and a fantastic team to solve this capacity constraints. Um, so we are staying, dare I say, hyper horizontally focused. We're going to develop technology that we need, but my goodness, if there's someone else out there that does it better than we do, we're going to bring them on as a partner, and we're going to move quickly because again, I can't say it enough times. This capacity constraint, it's a real risk in the industry, and if we don't get past this capacity constraint, we're gonna struggle. What the World Economic Forum says, the market could be over 2 trillion by 2035. National Science Foundation says no, actually 4 to 6 trillion by 2035. Well, not if we don't solve this capacity constraint, right?
Yeah.
So that's where we're focused, and that's why we're staying really horizontally integrated,
Mhm.
on purpose by design. So we're taking a really different, a novel approach to this, but it's only novel in space. It's not novel terrestrially, right? I mean,
Right.
uh, pick your favorite pick your favorite even big defense integrator. They're big system integrators that develop technology as they need, and you can't knock those big system integrators for the technology and the products they've brought to the market.
Yeah, no doubt, no doubt. So for your launch in December of 26, do you have payload space still available? And I guess what types of payloads would you be able to accommodate if there is space?
Oh, that's an awesome question. Thank you. I love it. Right now, we definitely have payload capacity available to the tune of about 20 kilos on that very first flight. On the second and third flights, probably closer to 40 kilos of space available. Um, as with all things going to space, we are, swap size, weight, and in particular Hermes power constrained.
Hmm. Hmm.
However, I mentioned Rogue Space before. I'll say our very first flight, we've got our lead payload is United Semiconductors. We're going to be bringing their first, so that will be the first. United Semiconductors has the moniker of being the first commercial company to create semiconductors in space.
Wow.
We, combined with United Semiconductors, will be the first commercial enterprise to bring a semiconductor material payload to space and back. So that's going to be really, really cool. The power constraint, we're trying to solve that again, right, with good partners. Rogue Space is moving along with us in a lot of ways, and they're going to have some extra power capacity in orbit. Now it's a little bit of a technological challenge. Can we access that power? So that'll be what happens in 2027-ish. The Hermes Alpha will be much more power constrained than its sister Hermes Beta. Will be much less power constrained. So by mid 2027, we'll have both payload and power. We'll have managed both the payload and power constraints on those vehicles. Once you get to Athena, that'll really be the workhorse. Neither power nor payload capacity constrained, at least not right now.
Yeah.
I look forward to the day that we are both power and payload constrained on Athena, because that'll mean we've really done something in the market.
Yeah, right. And as I understand it, and correct me if I'm wrong here, you do plan to reuse these spacecraft for multiple missions?
Yeah, I mean, nobody can answer the question how many times, right? Our goal is at least 10.
Oh, wow.
Um, yeah. Well, I mean, think about SpaceX, right? A much, much heavier duty cycle. Their
Yeah,
their initial stages, some of those are in the 30 and 40 times being reused, right?
right.
And that's a much tougher duty cycle than Hermes or Athena will have. So
Indeed.
the goal, right? But that's part of the efficiency of the model, right? The efficiency of the model. If we had to build a new spacecraft every single time,
Yeah.
we're going to lose out on the efficiencies, right? So what we need to do is we need to have a reusable spacecraft that's exceedingly robust. Is I This is hard to say, but Phoenix Hermes will be the first. I'll say the first fleet of small spacecraft designed for reusability, return, and ergo reusability, right? Um, some folks might argue that point with me, but we're going to be amongst the first to get that done. But Phoenix Hermes is paid for in its first two launches. So we get to 8, 10, 12 launches. We have a really efficient model, and we deliver that efficiency to our customers, so they're paying less money, and we deliver that revenue impact back to our investors. So we're efficient on both sides. We're efficient with our use of capital, and we're efficient with our generation of revenue, which I think is a real winning combination.
Absolutely. I'm sure investors will appreciate that for
I
sure.
hope I hope so.
So, from a commercial perspective, what do you see as, and I think you've mentioned a couple already in our conversation, but what do you see as some of the main use case opportunities here? Who's going to be launching payloads with you?
Yeah, if we look at our first six of our first nine folks that have signed LOIs with us, they're in-space manufacturers or microgravity researchers. Um, and then I would actually say that the vast majority of microgravity research right now is dedicated to developing this economy. So we see that as probably our main two use cases moving forward: microgravity research and in-space manufacturing, and we're designed for both of those. We have, I can't mention their name right now, but we have a really unique propulsion company that came to us, and they want to do a 6-month mission where they do multiple orbit transfers and so on. And then at the end, they want their product back. So that is getting into what we call the small payload market. I
Mhm.
think there's this going. This is Andrew Parlock's prediction here, but we're starting to see it, that there'll be just folks that are developing small payloads with comms payloads or Earth observation payloads that don't want to develop a whole new satellite, right?
Mhm.
And
Mhm.
maybe there's a reason why you bring your technology back. I mean, um, there's lots of reasons, but it's funny. I talk about this all the time. If you in space in delivery to space today is a little bit like it's a one-way trip, right? Something goes wrong, and you're a new company, that could sink your entire company. Well, now what if I gave you the option to put you for oh, by the way, for less money that you would build your own satellite, for less money than you would build your own operation center. So really capital efficient, but then I gave you the ability to go up, test your equipment out, get yourself the TRL 9, bring your product back, understand what went right, what went wrong. How would you innovate differently? We can't
Yeah.
even answer, we can't even answer that question today. So,
Mhm.
you know, we want to give people the ability to innovate differently and oh, by the way, get their product back. If we're doing comms payloads, why wouldn't you keep your comms payload up there for a year? Bring it back, upgrade your equipment, make sure everything's working correctly, and then if it's capital efficient, relaunch. Right
Yeah.
now, does that happen? I don't know. Right, that might not be the right use case, but at least gets the gears moving and how we innovate differently and how we think differently about space.
Sure, sure, sure. Okay. So I really want to thank you for making time to be here today. If somebody wanted to learn more about Space Phoenix, what should they do?
Well, you contact me. My name's all over the place. Get to my LinkedIn page. Space-phoenix.com is our website. We are upgrading the website. We hear a lot to say, you're such a cool company, but your website's not showing off how cool you are. We are upgrading that. But go to the website, you'll get my contact information, reach out. Um, we really want to help folks get to space and get back in a capital and time efficient way. um, and you know, get their product up there and get it back for delivery to Earth. I mean, there's a whole new economy we're creating, and we want to be the logistical backbone of it.
Fantastic. Thank you so much for being here today, Andrew. We really
Thank,
appreciate it.
Lisa, thank you. Really great conversation.
Absolutely. And I do want to take a moment to thank GuideForce for hosting these sessions. To learn more about GuideForce, you can visit guideforce.com. And we'll see you next time on the Tech and Space Leader Show.
Thank you, Lisa.